Hey, welcome back. In this video we are going to learn how to prepare aldehydes and ketones. I have selected the main reactions or the most commonly used reaction to prepare aldehydes and ketones. Without any further ado, let's dive into it. So, how we are going to prepare aldehydes and ketones? First, by oxidation of primary and secondary alcohols. You have to be careful, you have to oxidize alcohols with a weak oxidizing agent to stop the reaction to aldehydes. Because if the oxidizing agent is strong, it's going to convert them to carboxylic acids. So what was the common ones? Des-martin-pyridine, indimethyl dichloromethane, PCC and PDC. Did you remember the name? So pyridinium chlorochromate, pyridinium dichromate. All these three reagents, depends on what you have in the lab or what you want to use or what your professor suggests during the lectures, you can use to prepare aldehydes. So in this case, with three reagents is going to give the same product. So in this case it's going to be ethanol. Right? One way to prepare aldehydes. Now, if you want to prepare ketones from oxidation, you have to start from a secondary alcohol with each of these oxidation agents, but also with a cheaper one that is like chromium 3 oxide, and it works best. But if you treat this alcohol with chromium 3 oxide, it's going to convert that to carboxylic acid. Be careful. For secondary alcohols, it doesn't matter if you use one of these weaker oxidizing agent or a stronger one is going to give ketone. So in this case, cyclopentanone. Right, another way to prepare ketones. Let's move further. Let's move to the second way to prepare aldehydes and ketones. In this case, by partial reduction of carboxylic acid derivatives. If you start from it specifically with esters, in this case, if you start from an ester, you treat that with DIBAL-H in toluene, and after that followed by the hydrolysis. What is DIBAL? DIBAL is diisopropyl aluminium hydride. This compound here is going to convert esters to aldehydes, or is going to do reduction. So what is going to be the product? So propanol. Right? From esters, DIBAL, toluene, hydrolysis, you're going to yield aldehydes. By ozonolysis, another way that we learn from alkenes during their reactions. By ozonolysis, you break the double bond, and in the case that you have hydrogens, it's going to give aldehyde. In the case that there is no presence of hydrogen, it's going to give ketones. Be careful at this. So this is going to give two products. The first one is acetone, and the second one is going to be ethanol. Okay? Because you have the presence of one hydrogen. Another way to prepare, this works only for ketones, is by Fridel-Crafts acylation to the aromatic rings. So what we did, we treat that with an acyl chloride. You see, acyl chloride, the one that I mentioned in my previous video about the carbonyl group as a substituent. So in this case, what is going to give? An aromatic ring with a ketone group. Another way to prepare aldehydes and ketones is by alkyne hydration. You have to be careful in two cases. If it's a terminal alkyne, gives different products compared to internal alkyne, depends on what you treat that. In case you treat a terminal alkyne with mercuration, the mercuration is going to yield a Markovnikov product, and it goes in two stages. First with the formation of enol, and after that tautomerization to yield the ketone. So this is the enol. I don't know why it's enol, all from alcohol, in from the double bond. And after that it goes tautomerization to yield the ketone. In the case that you have anti-Markovnikov reagent, BH3 in THF, and followed by the hydrogen peroxide in pH8, you're going to yield an aldehyde, no Markovnikov product. Right? So if you have an internal alkyne, it's going to give two products, a mixture of products, because one ketone is going to form at this carbon and one ketone is going to format this carbon into different products. Both ways, with mercuration, demercuration, and also with BH3 and THF. So the products that you are going to get in this case, and the next product is going to be this one, right? Both ways, but in case you have terminal alkynes, be careful, you can yield either a ketone, either an aldehyde, depends on what you treat that. And then the final way to prepare aldehydes, with what I have considered here, is from reduction of nitriles with the same reagent that we used to reduce esters. So, in this case, going to give an aldehyde plus NH3. Right? These are the most common ways to prepare aldehydes and ketones. Right? Now, in the next video, we are going to talk about the reaction of aldehydes and ketones. That is one of the most important videos of organic chemistry. So look forward to see you all there. Peace.